Okay. What did you say was the domain for your first function there?
Negative infinity.
Guys, tomorrow is a big day. You want to be ready. So everything but 2, right? So problem A, the domain is everything, or Thursday. Our next class is a big day. So the domain for A is everything except 2. Denominator can't be 0. And then what about B? What's your domain for B? Everything, negative infinity to infinity. Because what bothers us? Denominators bother us, and so do radicals. And if you don't have a square root, and you don't have a denominator, then you are good to go. Where is the horizontal asymptote of this function? Y equals 3/4. Now again, it's so simple, but it's so dumb to miss these points. If you're talking about a horizontal line, you're crossing the y-axis, so you are y equals. If you're talking about a vertical line, you're crossing the x-axis, so you are x equals, right?
Yep.
Okay. What are the implicit functions? Well, did you move the x to the other side?
Yes.
And then y equals the square root of 7 minus x, and negative the square root of 7 minus x. Don't you dare try to distribute that negative. No, no, no. When you write your implicit functions, the 2 radicals are going to be exactly the same. One of them is going to have a negative out in front. Okay? That's it. Those are your implicit functions. Okay, given these, we need P of Q of X. So we take whatever Q is, which is this, and plug it into P, X, X's and P. This says put the Q thing into P. So we would have 3x squared plus 2. That's it. That's what we have. That's all we have. And then sketch this guy. Now, in order to sketch it, you have to remember what your logarithmic function looks like. So your logarithmic function has an asymptote at 0, an intercept at 1, and looks like this. That is your logarithmic curve. BFF, gotta know them. What change is there in that equation? Right 2. That's a right 2. Right 2. That's right 2. So everything in the picture is going right 2. So you're going to pick that asymptote up, and you're going to move it over here, so now it's at 2. And you're going to pick that dot up and move it 2 units, so now it's at 3. And then you're going to sketch in your curve. Now you can't, with these BFFs that have asymptotes and stuff, you can't just randomly draw it. You have to put in those things. Okay? All right, how would you have done had that been a real quiz for you?
I got the last one.
You got the last one wrong with the rest right?
Yeah, I grabbed it on.
Now I need you to fold the paper in half so that all you see are the problems. Because on the back I have the answers also, but I don't want you looking at those yet. Only the problems. right, I want everybody right now to look down through, there's what, 11 problems. I want you to look down through and find one that we need to practice. So just take about a minute. You're gonna find one that we need to practice. You don't need to shout it out, you need to just chill out for a minute. Pick one that we need to practice, and then we'll go around the room and we'll practice whatever we need. Story?
Yes.
The first you only had J term, how many years ago that's
Those are freshman year. Yes.
Okay, I did a crochet thing, so I had the desks in a big, circle, you know, moved around, and at the end of the day, the kids are probably, they're crocheting, and I said, hey, you wanna take your stuff home, that's great, I leave it here, that's fine, I sit on the table, so I had all this yarn, all these books, all this stuff, okay? Well, apparently, the cleaning crew decided that none of that was important. So they cleaned off the desk, they threw it all away, including, I had boxes of yarn back there, extra yarn, they threw away all my yarn, and they threw away all the kids' yarn, and all the hooks, and all the equipment. And so, I came in the next morning, and I'm like, oh, panic. So I go and find Mrs. Schiller, and she could narrow it down to, my girl was, the cleaning it down, was supposedly the last one to go out to the dumpster. So guess what I did that morning? I went right out there and climbed in there, and I found, luckily it hadn't rained, that would have been cool. But I found almost all of it. I didn't get all the hooks, and one kid's yarn was missing, but I found all the rest of it out of the trash. We got
That's
it.
actually, did you have gloves on or no?
Huh?
Did you have gloves on or no?
Yeah, I was in the freaking
She was
dumpster.
on the dumpster with no gloves. I know, she was like,
I wanted like a wetsuit or something.
Oh, yeah. Well, I didn't know she had down in dirt. Like, you're like actually sitting in the dumpster.
Time's over. Now we're
You'll
gonna,
probably get down in dirt.
now we're going to look at
Not enough.
Jake,
Oh, nice.
9. We are going to sketch this piecewise function. Now, if you are choosing to work with me, you will need a piece of paper. All of the action in this problem is happening at 2. So right here is where the action is. Okay? Right here. X is 2. Now, I am going to, with my pink marker, I'm going to graph the top line, which is y equals x minus 1. Tell me what shape I am graphing. It's a line. And the linear function, or the identity that you memorized, was this, right? What's happened to this one? Down 1. So now, I'm going down 1. There it is. Now remember, all the excitement is right here. That will be an open dot. And it will be shaded to the right. So this is not important anymore. All right, Jake? Now, with my red marker, I'm going to graph the next line, which simply says y is 5. But y is only 5 in one place. Y is 5 when X is 2. That's a point.
Yeah.
That's the point, 2, 5. And it's a solid dot because X equals 2. 2, 5. And then I'm going to go back. Y equals negative 2X, which is another line. It's going to go through the origin and have a slope of 2 over 1. So down 2 over 1, down 2 over 1, down 2. There's that one. All the action is right here. That is another open dot. And I'm going to keep that side of it and get rid of that. If you want, if it looks better to you, you can get rid of that dividing line. You don't need to, you can leave it in there, I don't care. But there you got it. Now this time, we have 3 dots, because we have 3 parts of the problem. Always, no matter how many dots you've got, always they're going to be in a line. And only one of them can be closed in, because this is a function. So one of them can be closed, all the rest of them have to be open. All right, Jake? Got it. All right, who else has one?
Sure.
Ronan?
Number 2.
2? Are you following the crowd?
Ooh.
Well, Dana just found out that I wanted to, so.
Oh, wait, let me look at that. Oh, okay, so here's the given. And the question is it even, odd, or neither? Okay, now, let's remember what it means to be even. What's it mean to be even?
Y. Symmetry of the y-axis. Is the y-axis.
It's got symmetry about the y-axis, and what's our test?
Negative, you substitute the y for negative x. Or
Change the sign on x. X. You change the sign on x, right? And when you change the sign on x, it isn't supposed to change your y, right? It's not supposed to change your equation. So let's look at what happened here. I put in 4, and I got negative 2. Okay. Then I changed the sign on x, right? What happened to y? It stayed the same. It stayed the same. So changing the sign on x didn't change anything. That's what it means to be even. This is an even function. An even function. It might help you too. If you plotted these points, there's the first one, here's the second one. Do you see symmetry across the y-axis? So a visual might help you too.
But you won't give us an easy one like that.
What do you mean?
So like on the quiz, there was one like, and like an actual like line, like a y equals.
Oh, yeah, well that doesn't matter. So if I gave you this equation, you would just change the sign on x. If you're testing for even, you're going to change the sign on x. Is that going to give me the exact same equation that I started with, or is it going to change things? It's going to change it, so it's not even. Here, I changed the sign on x, and it didn't matter. That's what even means. This is not even.
I mean, how do you know it's odd?
What's the test for symmetry for
Switching
odd? You change both. So if f of 4 is negative 2, if I'm odd, so given this, if I'm odd, f of negative 4 would have to be positive 2, because I change x and change y. That's what origin means. Okay, so that would be, given this, that would be odd.
What's the one where you swap it around?
Identity, that's not part of the even odd conversation though.
Yeah.
Even is y-axis, odd is origin, that's it. But yeah, we do have a test of symmetry about the identity time, y equals x, we switch y and x. All right, who has another one? 6. Find the implicit functions for 9y squared equals x. All right, we did one of these a second ago on that quiz. How do we find implicit functions? We have to get y by itself. So y squared equals x over 9. Right?
Yeah.
And then I square root. So y equals the square root of x over 3. Or y equals the negative square root of x over 3.
You just put like plus minus. Or do you have to like write
Do you care if we put a positive there or not?
Unless there's 2 answer blanks, then you gotta separate them.
Do you care if we just put a plus sign there, just like on like a positive one?
Put a plus there, that doesn't bother me.
Will implicit always be plus or minus, or a square root? I mean. Or wait, what was it? What?
If we're finding implicit functions, we're gonna have to have some kind of thing here. So as long as, if you are square rooting, it's gonna be plus or minus. All right, what else?
Do number 4.
4. We want the composition. So someone has built the composition already, Q of P of X, and come up with 8x squared plus 5. And our job is to work it backwards and figure out what are the 2 little functions that if you put the P into the Q, you would get that. There's going to be more than one answer, possible answer, because I only have 2 functions, but I have how many things going on in this problem? 3. There's a squaring. We need to square. We need to multiply by 8, and we need to add 5, right? And PEMDAS tells me that they have to happen in that order. Okay? So I need those 3 things to happen in that order with just 2 functions. So, P starts it. P is first. So I could make P, what do I gotta do first? Gotta square. So I could make P be x squared.
Then 8x plus 5.
And then Q would have to times by 8 and add 5. Now, when you write these, it's always x. You're operating on x. So this function squares. What does this one do? Times is by 8 and adds 5. Now, you could also build a P like this. And then Q would take that output and add 5. Okay? Either one of those. All right, who else found something on this paper? Huh? 1? Find the domain. Well, we kind of talked about this already. What has to happen, or what am I looking at in a domain problem? Denominator cannot be 0, and whatever's under here has to be greater than or equal to 0. As long as you remember that, you can do every domain problem. So I look at the first one. I gotta quit shrinking So it has a denominator. So x plus 2 cannot be 0, which means x cannot be negative 2. It also has a radical, so 5 minus 3x has to be bigger than or equal to 0. Negative 3x has to be bigger than or equal to negative 5. And x has to be, watch it, less than or equal to 5/3. Now I gotta write an answer, and it's gotta have both of those. So I'm gonna look at it on a number line, that always helps me. Here's 5/3. I went all the way, except I have to skip over negative 2. Would you agree with that picture? So negative infinity to negative 2, or negative 2 to 5/3.
Would you also just think of it as like, maybe like the vertical asymptote?
That would be a vertical asymptote, yep, and negative 2.
And then that just means that we can't do that.
Yep, it can't equal that. All right, next. Now, look at the next problem here in this domain section. It also has a denominator. So what do we know about denominators? They can't equal 0. So x cannot equal negative 1/2. So on a number line, it's the whole number line except negative 1/2. So negative infinity to negative 1/2, or negative 1/2 to infinity. Kelly, you following along here? All right, what about h? What's the domain here?
All else.
Yeah,
All else.
why?
Because it's a
No denominator, no radical, no square root. And k of x plus 2 has to be bigger than or equal to 0. So x is greater than or equal to negative 2. So negative 2 to infinity. And again, if you're having a hard time getting from here to here, draw it. Solid dot at negative 2 going that way. As soon as you draw it, you can write that interval pretty easily.
Can you do 5?
5. Alright, 5 says we're going to list all of the asymptotes and holes. So what do we have to do first? We got to factor it. I heard somebody say that. We're going to factor it. So what can I do on the top? Take out a 2. 2x squared minus 7x minus 4. I can take a 2 out of the bottom also, right? I have an x, 2 and an x. Can my 2's cancel?
No. No, can't.
Yeah. Now, that isn't gonna make a hole. Holes happen when we cancel, but we have to cancel out x's, okay? So the 2 isn't gonna impact anything, it's just gone. Now, what about this though? That needs to be factored. This is gonna cause some of you issues, and you're just gonna have to jump in and try something. Clearly, I need a 2x and an x, right?
4 and 1.
I need, yeah, 4 and a 1's gonna work great.
A negative x. Oh wait, you know what?
Don't that give me negative
Yeah,
8
negative
and positive 1?
Yeah. Yep. And then you got
More.
Yeah.
6 minus 4.
Alright, so I am factored. Lexi, you still with me?
So it's
You gotta get it factored first.
so 4
we're going to have a hole at x equals 4, yep. Now, don't write x equals 4 though. A hole is a point.
4.
So it's not gonna be 4, 0, I don't think.
Oh, you plug it in.
I gotta plug it in, and it's gonna be 9 fourths. Where does the x come from? What got canceled out? Where does the y come from? What you get when you plug it in to your reduced problem. All right, I need vertical asymptotes, horizontal asymptotes, x-intercept, y-intercept. All right, here we go. Do I still have a denominator?
Yes.
That means I have a vertical asymptote. And that vertical asymptote is where? X equals 0. Vertical asymptotes come from the denominator. What makes the denominator 0? X equals 0. Now, horizontal asymptotes come here, so that would be y equals 2. Now, what do we mean by intercepts?
Zeros.
We need
The
no.
axis, what
We
across the
mean where we cross the axes, right?
axis? Yeah.
So if I am on the y-axis, my x is going to be 0. Uh-oh, can x be 0 in this problem?
No.
No.
So there's no
So
y.
there's no y-intercept. If I'm going to be an x-intercept, then my y is 0. So put 0 right here.
It's gonna be
Nope,
negative
it's going to work
0.5.
out great. We're going to multiply both sides by x,
Negative 1/2.
and I'm going to have 0 equals 2x plus 1 minus 1, divide by 2,
X equals negative
1/2, comma 0 is my x-intercept.
Will the horizontal asymptote always be the same as simplified problem
Huh?
like, so you have the horizontal still too?
Yes, always gonna be the same, always the same. I got time for one more, then I gotta pass back your last test, because I want you to see how that was graded. So, let's do one more. From this page or a different page, I don't care anything, what do we need to practice?
Whoa. Okay, you can.
3. Number 11.
11?
Yeah.
That's.
So, in number 11, I have drawn a picture. And your job is to figure out some information from the picture. Okay, so I think I've got it. Okay, so at x equals -1, so at this point right here, we have an absolute minimum. That right there is the absolute lowest point on the graph. Would you agree with me?
Yep.
So that at where x is -1, that is an absolute minimum. What about where x is 1? What's that?
It's relative max. Relative max. Relative and absolute.
Yeah, that's an absolute maximum, because isn't
Oh,
that
it's
the
an
highest
arrow.
point on the
I thought it was
graph?
an arrow.
Yeah, there's no arrows.
Oh,
There's no arrows. Now, if there were arrows, that would be just a relative max. But there's no arrows, so that is an absolute maximum. What about this point? What's he? A relative minimum. The relative relative minimum. Now, while we're on this, another thing I want to talk about is, okay, this is from -3 to 1, 2, 3, 4, okay, on that interval right there. I want you to tell me intervals where we are decreasing. What are the intervals where we are decreasing? Jake?
-3 to -1.
-3 to -1, very good.
1 to.
And 1, 2, 3.
Yeah.
What does decreasing mean? Decreasing means when you draw over it, you're going down. So you're going down here and you're going down here. Now, where are the intervals where we are increasing?
-1 to 4.
-1 to 1
3 to 4.
and from 3 to 4. Perfect, beautifully done. All right. Now, we've done almost this whole sheet and the answers are there. I gave you 2 yesterday, or whatever day that was. So you got plenty of practice to do if you wish. I am going to hand back your last test now. And I want you to look at it, see how it's graded, so that you're ready for tomorrow.